Hey everyone, welcome to Austin LangChain AI Middleware User Group, or AIMUG as we like to call ourselves. Funny, I shortened this so we could really fit everything in the schedule. There we go. So today's agenda at 6:23. We kind of had some time where we can get to know each other. Again, if we want to continue the conversations, we have Q&A. But also we have an after party at the tavern, which, please continue the conversation. I don't want to stop anyone connecting. Today on the agenda, I'm going to go ahead and give you little intros. Good to see you. Give some intros for Austin LangChain, or AIMUG. Who's new here? 1, 2, 3, 4, 5, 6, 7, 8. Okay, cool. So we'll give you a little talk about who we are, what we do, right? And then y'all showed up on a really cool day. So we have 3 talks specific about LangGraph and LangGraph derivatives. 3 if Anu will show up. If not, we'll have 2. And then we have 1 remotely from we actually have a Panama branch with 100 people, 100 members. And Paul Phelps is down there, and he's going to give a talk on AI project management. So, hey, there's Paul saying hello, or Aaron. So anyways, that is not the right name. Wow, Ryan Booth is not presenting on this. So we'll have basically me, I'm going to give a talk that the LangChain team kicked down some community slides. So they're giving us training material that we can share. And he's going to talk about RAG on LangGraph. Collier is going to give hopefully the first in a series, or continuing in a series of deep agents. Yep, okay, and then Paul's going to talk about AI project management, frameworks, pitfalls, and stuff. And that is getting fuzzy. I don't know what's up with this technology. So for those that are new here, you can catch up with what we do. If you go to AIMUG.org, you can scan the QR code, or you can just type in AIMUG.org, click on Learn, and what we do is we take the videos that we capture here, and we run them through AI, and we create documentation out of them, and we put them on YouTube. So you can catch up with what we do. It's pretty cool. So last month's talks were posted pretty early, and you can also go to our YouTube channel at AIMUG. I want to really figure out what the heck's going on with this cable. Oh no, here. We're just going to see if that clears it up. What do you know? I want to thank our supporting members here. So we are member supported and corporate underwritten. So members, I think we had 25 of them that kick down either coffee, a pizza, or whatever. Once a month, and help support what we do here. It helps drive our cloud costs down, our software costs, our AV costs, all that stuff. It also helps us with our interns and whatnot, making sure they get good pizza. I want to thank our corporate underwriters. So we have the Center for Government and Civic Service, I always misspell it on here, which hosts us here at Austin Community College Rio Grande campus. They are gracious to allow us to trade some mentoring of staff and students, and to be able to operate as a public good, providing learning back into the community. I want to thank LangChain AI, which Harrison's been a great supporter from the start of this a couple years ago. They're nice enough to buy pizza for us today, so if you're eating pizza, you can thank the folks over at LangChain. And then Always Go Brands, which is my company. We've been supporting financially and with time for 2 years now. So what do we do here at AIMUG? Fundamentally, we are a working group where we're learning. What we do is different members will go ahead and explore a concept. It might be a new technology that's come out this week, this month. Half the time people will be coding on their laptops right before they come up and take the stage, right? And why do we do that? AI is moving so fast. Right, and would anyone disagree that the developments in AI are moving like light speed, right? And so it's really hard to keep up on it. And what we found is by breaking apart the problem domain across our community, and then having people try it out, and then here's what I got working, here's what I learned, right? And they're doing it in an environment where we're cool to each other and we're not gross. So those are our 2 rules, by the way. Just be cool. Don't be mean, don't be a dick, don't be an asshole. I need to cut that out, this is making it on public television. But treat each other nicely, because when you're up here and you're presenting, especially when you don't know it, it's kind of like being a kindergartner. Be nice to people, it helps us learn together. And then don't be gross, we know being gross is, right? So where and when we meet on the first Wednesday of every month here at Austin Community College, Rio Grande campus. And then with the exceptions of when Colin's busy with product launches and is working 18 hours a day for 6 weeks, we normally meet out in town, usually about 2 weeks later for a hacky hour at a local coffee shop or bar. Hang out, write code, whatever we want to do. Okay. And then also we have on Tuesdays at 5, we have office hours. So if you pop on our Discord, there's a link. It's also on aimug.org. There's a link. Usually, I don't know, I see a bunch of faces here. I actually saw your face. You turned on your camera. I'm so happy, Rob. Yeah, usually have like 10 or 11 people and just checking in, working on whatever's hot on the projects. If you have a question, I'm usually not the smart one on there, but people can answer them. Yeah, Rob's nodding yes. I'm not the smart one, but just joking. Anywho, so we have our virtual syncs for our for office hours, our hacky hours mid-month, and then our labs and showcases. If you want to present, it's pretty easy. Just ask, right? We structure it normally around 15-minute thunderstorm talks. So usually like a 12-minute talk with 3 minutes for Q&A. And my only ask is that find something within the LangChain ecosystem to tide the thread. It doesn't have to be all about that. It might be just like, there's some new AI framework of the day, and then we all believe it's going to take over the earth. Show how you can wrap it in LangGraph and run it as a node, right? Because you can. It helps people tie things together and makes it so we're not just like everything to everyone. So talks and demos today. I'm going to kick off with Intro to LangGraph. Thanks to the LangChain team. Anu will show up when she shows up. Oh, hey! Oh my God. You think with the glasses I'd be able to see people? I know. It just makes me look smart. Cool. So you're going to give a really great talk on RAG. I'm going to give my talk first. You're up too. And then I think Collier's going to really, you should pay close attention to all of them, but like what Collier's exploring with deep agents and this crossing over of how Claude Code can run on Claude Code type styles of easily iterated agent structures can run on top of a bulk synchronous parallel graph, LangGraph. It's really, really powerful. So on that note, be cognizant of time, we're gonna kick it off with my stuff. So hi, I'm Colin. I'm a local entrepreneur. I'm co-founder of Always Cool Brands and founder of Always Cool AI. We make smoothies, cow milk, pie crust for other people's brands. You go to Sprouts and get our stuff under Sprouts banner right now, as well as a number of other products in the pipeline. We specialize in basically taking poison out of the food supply. We make foods that don't have any dyes or additives, stuff like that. Won't give you cancer, make your kids stupid. 3 years ago, I left an engineering leadership position at Oracle to be a focus on public good. This is part of it. So is Always Cool. So for me, I don't work for LangChain. I was an early LangChain user. I am a user. So we use LangGraph all across in 5 different ways, five different applications on their website. I have it in 2 different places on Ingress, my ERP system, and then have it in a number of other places with different scripts here and there. Also a community builder. Started this 2 years ago because I wanted to find nerds like me doing this stuff. I used to call myself a 10% developer. I then upgraded to 50% developer, and now call myself an 80% developer, thanks to everyone here, because you've been really cool and shared the knowledge. So kick it off. This is a really important thing for us as a community. Harrison and team, they've now started distributing training materials out to the community. So not only can you go onto LangChain Academy and take the courses, so if you go to academy.langchain.com, there's a bunch of quick start courses for those that are new, right? Highly recommend it. But they're also distributing out content like this. So we're going to talk a little bit about LangGraph right now. There's 3 things that you might hear about with LangChain: LangChain, LangGraph, deep agents, right? LangGraph is we'll talk about it right now, but it's basically an underlying framework that allows you to run like LangChain, deep agents, other stuff inside of it. So we're going to talk about building AI systems. We're going to introduce LangGraph, and then we're going to show the ecosystem. So let's talk about building AI systems, right? So when you talk about like a simple interaction with the large language model, right? It's very limited, right? So you start, you talk to your LLM, you get to end. It lacks context, right? So good applications, they follow a control flow, right? So you might do step 1, step 2, step 3, you know, a reason and act agent, right? Maybe a simple path, and earlier on, multiple years ago, LangChain was a chain of transformations that we would do with our inputs and outputs, right? So this control flow forms a chain, right? So when you think of like an example search or a RAG chain, the question goes and hits your vector store. That vector store, the retrieval from the vector store gets passed to the LLM, and then out comes the answer, right? So the agent is not really is equal to control flow defined by the LLM, right? So you might have the start go to step 1. The LLM may choose it to go back to the start of step 1 and proceed to step 2, right? You might loop through things. So you know, you've probably heard that an agent is kind of like a for loop, right? At the end of the day, right? So if you think of a chain of simple chains of synchronous execution or processing of a start, step 1, step 2, right? It's developer defined. An agent itself, you might have the LLM define that control flow, right? Simple. So if that agent's control flow is defined by that LLM, right? I think I actually went backwards. My bad. Let me go. Whoop. So agents themselves, they may use tool calling. So does anyone use tools with their agents right now? Okay, so about half the people, right? So if you think of it in this case, right, you have the natural language input, right? You have a tool, which may be just it may be a calculator, it may be a Tably web search, it may be whatever, right? Those are bind together with the LM. The LM binds that tool maybe through an MCP, right? And then outputs the payload needed for that tool, right? The simplest design that we talked about for the loop is a React agent, so a reason and act, right? Where the process is started, the tools are called, right? And then the tool happens. The LM observes that response and then loops through to the end, right? The simplest example is like, I don't know, probably my Perplexity web search MCP, right? So think about React agents. They're flexible, but they can go in any direction. You know, and I think later today when Collier's starting to talk about deep agents, we'll see the power of being able to really, really, really go any direction, right? It's not a bad thing, but there are some cases where you don't want it to. So I brought up an example of how, you know, I have 5 different applications on my web front end that we use for like label design, FDA validation, nutrition facts calculation, places where allergens, religious context, like halal, kosher stuff where like if you get it wrong, people can die, right? So in this case, do I want to put a React agent on there? Or do I want to put a directed acyclic collector graph? Do I want to actually constrain what it does? I want to constrain what it does, right? So we talked about, and the reason I want to constrain what it does is because reliability and repeatability are not something you're going to get, right? Because we know that anytime we query an LLM, they're non-deterministic. I might get the different thing out of it each time, right? And in things like life safety or nutritional safety or nuclear safety or whatever, right? You know, you generally want to have some sort of repeatability and reliability. So why are they unreliable, right? So the task may be ambiguous, right? LLMs themselves are non-deterministic, right? The tool may be misused, right? You might ask a tool to do something that it's not best at and it may respond and whatever. There may be a bunch of dependencies inside of there, right? So the question is can you have both? Can you have the deterministic nature of a specifically defined chain and the flexibility of a for loop that has access to tools? Well, that's kind of what LangGraph's for, right? So what is LangGraph? LangGraph balances agent control with agency, right? So when I think about LangGraph, the most important thing for me that I use is controllability. Define both explicit and implicit workflows. Because there's basically a graph or a path of a bunch of nodes and edges, I can specifically state 1, 2, 3, 4. I can basically define my functions. I don't I don't always use LangGraph in an LM application. A lot of times I'll use it just as in Python to deterministically order my functions, and then I can log it to OpenTelemetry, right, or LangSmith, right? But controllability is a really, really big thing. Other things that are really cool with LangGraph, and Collier has a lot of great experience on this one, is persistence, right? So then able to do human in the loop, right? And maybe you send an email out for human in the loop, and it might take 6 hours or 6 days for that response to come. Well, what if you're running in Cloud Run? It's going to go away, right? So with LangGraph, you can have persistence in different data stores, like Postgres, Redis, whatever, even file in some cases, right? We talked about human in the loop. So it allows natively built inside of it, human in the loop. So you want to pop to Slack, you want to pop to email, you want to pop to a console. It provides a nice, easy way of inside of that graph. Okay, I made a decision. Now pop to a human to get verification before it comes into the next step. And then streaming. So the ability to go ahead and expose any event or token as it occurs, right? So LangGraph works with or without LangChain. Most of the time, I don't use LangChain with LangGraph. Although with LangChain 1.0, it's basically the LangGraph React agent. So there's like the classic stuff that moved off, right? And then it integrates really easily with LangSmith. There's a LangSmith SDK. You can pop into your graphs, and you basically define your key and your endpoint, and you can set your project, and it's right up in LangSmith, and you can basically tell it to output in OTel. And if you want to output it to maybe an OTel collector and you want to fan out to a stack that you're using for elements of judge, you can do that too, right? So there's a lot of really, really cool stuff, and it's just like super simple. It's a lot easier than putting like OpenTelemetry decorators in every function and whatnot. It just kind of works. So like, again, 80% programmer, that means kind of lazy at times.
At the top you have LangGraph application docs, agent control, agents. So does that coincide with step C being that you have human in the loop to facilitate human guidance, which I would foresee as a means to protect against unwanted responses?
No. Well, I mean, you can use human in the loop for a number of reasons. Like one of the use cases I'm building right now for my ERP system, right? So like I'm using LangGraph to do LangGraph in conjunction with like, I have 4 different image processing engines that are coming in to process like stamped bill of ladings when like product comes off, comes into warehouse, right? And in this case, that processing node may move forward into a node that releases an invoice, right? Where I'm going to go ahead and basically accept financial responsibility for a certain amount of product loss. And I may want to do human review at that point, right? Because it's my money, right? Literally, it's my money, co-founder. Scary at times. Those are things, but it may also be convenience in that maybe you're in this case, like I'm using like PyTesseract and Cloud Image API and a couple other things, like Google's OCR thing sucks. But in this case, you may want to go and do validation that the output actually matched it. You might want to have a human doing it. That's just like one case for me right now. But there's financial applications, call center ticket management applications. If you're going to think about like Jira Service Desk, right? If you're going to go back and forth, you can have that human. You can have that function replicated in your agent stacks. You can also very easily tie it into like Slack and whatnot, right? So if you want to move this to the next step, move this ticket to the next step. Maybe you have a deployment that's going on, right? And you want to go ahead and validate that the human read the CI system reports. You know, that's an example, and there are many other examples, and it's flexible is the whole point, right? So with controllability, for me, and I talked about like my use case for our nutrition facts validation, verification, creation, and our FDA label verification. People can die if you screw it up, right? And I'm legally liable as an officer in the company. And so, like, yeah, I want to make sure that it does every step, every time, and I want to make sure that's logged, and actually log it to LangSmith because like it's there, right? But there's many other things you can think of. If you're doing infrastructure work, you probably want to do the same thing each time. Maybe if you're having configured Kubernetes infrastructure, same thing every time. I don't know. A lot of other things. So for controllability, you don't have to statically define each step. You can put an agent in between each step and say, okay, choose which step to use. You can branch, right? I might be getting ahead here, right? So you can basically express control flows as graphs, right? So there's this thing, this node, a start, a node, which is basically a step, an edge, right, which is the path between your nodes. And you can put some LMs in the middle and use it to direct things to loop back, to have things pass forward. There's some other cool stuff that you can start to play with called middleware that you can loop onto this as well. So you can basically build these object structures into it. So the thing with where we talked about with the chain earlier of step 1, step 2, step 3, and then a agent, which is the for loop, right? Is you can have both. Is really what it is. So you can build your LangGraphs as flexible as you want, as a React loop or React agent, or as static as you want. If like an FDA, which got FDA certified FDA certified scenario, or maybe a supply chain or finance, right? So for controllability is also really important, right? So the LangGraph agent, right? So basically. You can basically share memory across the graph itself. So, in many ways we handle memory, right? But you can basically store state and memory in Postgres and Redis. You can, if you're using, I'll let Collier go into how you can do it, deep agents. You can do things as files. If you look into, I'm not going to steal any of Collier's thunder, but there's some really, really cool stuff, and all runs on top of this graph framework, which is effectively an implementation of anyone knows what Hadoop is? Okay, I just made myself look really old. Okay, anyone know what Pregal is? Anyone know what bulk synchronous parallel is? Okay, well, bulk synchronous parallel is how Facebook computes every single like, comment, connection in the entire 4 billion person Facebook network in on 39 commodity servers in like 4 hours. Right? It's a really, really cool thing. It's one of the reasons that Harrison really blows me away, right? So you can basically you can route flow. You can route control flow based on LM decisions, right? So you have this map of where your agents can go. You can use LMs to get there. So the LM LangGraph allows for developer plus LM control flows. So you can, as I said, you can statically, you can basically make it static. You can make it kind of flexible. You can make it stupid flexible. And then you can do this thing called subgraphs, right? And this is something where I'm trying to figure out how I want to do it myself. So you can you can write a graph, throw it behind Fast API, spin it up, throw A2A on the front of it, register register an A2 endpoint with whatever your your service discovery, your service framework, service network is inside, and basically run AI microservices, right? You can also do a graph of graphs. And so you can basically have reusable, composable agent graphs that you can use. Kind of cool. For the controllability, you can branch. So you don't have to have a 1, 2, 3, 4. You can basically go parallel. You can also basically do MapReduce function with it. Oh, what do you know? You can basically do a MapReduce function where you can split a complex job into a bunch of small jobs and then bring that back and bring that forward and reduce that to an output to your user, giving you access to multiple cores, multiple flows. I've also seen people do, I've heard people doing like SpecDeck, speculative decoding with it. You do a lot of really cool stuff, both here but also in middleware. The really interesting thing is it solves memory, right? So the graphs themselves, right? Think of this as a graph A, this is graph B. They basically can write and read checkpoints into a state database, Postgres. So you can also do this. There's like a hosted platform, LangSmith Cloud, that if you don't want to like fiddle with the stuff, you can. So the persistent allows for human interactions. I kind of talked about this earlier, in that if you're going to do human in the loop, like if you email me, I don't know, if I'm writing code, I might get back to you at the end of the day, right? I don't know, I try to be good on email. We were really bad recently. And I brought this up earlier. If you're using Cloud Run or any sort of, or maybe using like AWS Lambda or whatever you do on AWS, I'm not that guy. Kevin's in the process of building one. You can basically store that state. So when that process dies, it's fine, right? The human loop comes back in, hits like the webhook. The graph comes back to life. It can pull its state out of that database, right? So it solves just real functional problems. The other thing that allows you to do is that persistence allows fault tolerance. So in this case, we saw the agent fail, right? So agent 1 split in the graph, right? Connected agent 2 and agent 3. Agent 3 failed. Because the persistence is in the database layer, you can respawn that agent, and that's fine. You don't have to write that. It's kind of cool. Also, I should actually remember this is in the further slides. Because it's a directive acyclic graph, 1, 2, 3, 4, 5, 6, 7, 8. You can basically move forward and move back, and so you can go back in time. So if you're trying to figure out like what the heck happened, you can do replay. So we talked about human in the loop. So you can put breakpoints within your code. So step 1, between step 1 and 2, I need a human to approve it. You can break it in the email console, terminal, Slack, Discord, all sorts of cool things. And it supports streaming, which is kind of cool, right? So we might use that, in our applications. So how does LangGraph fit within the LangChain ecosystem? So LangChain itself is it's basically the React agent out of LangGraph now. All the old LangChain code is like in LangChain legacy, right? So basically, this makes it really easy to prototype up a React application or an AI agent. You can use it for whatever you want. I use it. It's okay. It works. There's people who argue endlessly about whatever framework is the best. Everyone can have their opinion. You can run them all inside LangGraph. So, but LangChain is 15 million monthly downloads, 100K apps that are delivered in production. There's a lot of large production enterprise users on it, and about 3,000 contributors is open source code. LangSmith is a commercial platform that is used for logging and log management. Hey, what's up, man? Good to see you. So LangSmith, I always say this, again, I'm a user, I don't work for LangChain, but like I do consume their code. So if you use someone's open source code and you got to choose a for-pay platform for something and that open source project offers one, like makes sense to throw some coin down. It's how Harrison makes his money. He has 90 employees doing stuff, so we can help him out. But it works, right? And it's pretty big. It's about 30,000 active monthly teams on it. And I talked about my use case, right? I can easily, just with 2 lines of code, 2 lines in my env file and the LangSmith SDK, have my graphs and agents logging. It's pretty cool. In the larger ecosystem, there's the open source tools of LangGraph and LangChain and the integrations. That's mostly what we deal with here, right? And then there's like a commercial cloud if you want to like have them do stuff for you and you don't have to think about the low-level stuff. And then LangSmith, which is pretty cool. And then like it still allows you, if you want to fan out to like an open source stack and you want to use whatever debugging tools you want or whatever elements of judge you want, totally supports it. So at that point, we'll open it for Q&A before we get Anu up here. Does anyone have any questions about LangGraph? So I'm learning it too. Yeah, what's up?
Is there like an accepted and solid front-end interface for setting up the graphs? Because every time I've used it, LangSmith has been good for visualizing it, but not for manipulating anything in any way. Is there anything that people use for that? That's
I use Claude Code for that. So to repeat the question, so I haven't heard, is there like a visual way of messing with the LangGraphs? I use Claude Code, which is not visual. The LangChain team just released a visual agent builder, which runs on LangGraph under the hood. It just came out last Thursday. I haven't tried it out yet. Does anyone else know? Like LangFlow is more about LangChain based. Does anyone else know of any visual LangGraph builders? Yeah, yeah. Ricky was like an N8N workflow. Well, the N8N has an MCP. You can go ahead and build it itself. So it's like you can drag it. But I don't know. Any other questions about LangGraph or whatever? Cool. Well, thank you for your time listening to me talk about LangGraph, and thanks to Harrison and team for kicking down community slides. Now,
hey everyone. Hope you're having a great evening. I love Colin's talk, and mine ties in very closely with what exactly he was talking about, the state context management and also the principle of retrieval augmented generation in enterprise AI. Now you might ask me, why am I eligible to talk this? Well, I have tried LangGraph, it's amazing. Thanks to Colin, he's such a huge supporter of this amazing community. I started off with LangGraph a couple of months back. I'm not a veteran in LangGraph at all, but I've definitely seen a lot of amazing use cases within LangGraph. So why am I here? I'm Anupama Garani, as you all know, and I work at PIPCO, and I lead Gen AI initiatives. I basically use Azure Stack there. We have a bunch of global products, which is retrieval augmented generation enterprise-based, and I am here today to talk about some of my experiences on why retrieval augmented generation use cases crash and burn in enterprises. So with that, let's start off. Well, I already covered that. So the agenda today is going to be brief. We'll talk about the AI landscape in 2025, what's RAG and the landscape of it, and what are the production RAG failure zones. And I'd be diving deep into one of these different production zone failure, which is the static RAG. This is something that fails silently without people even realizing, and sometimes we also drive away a lot of users because there's not a lot of context while the users are having the conversation. Then I'll briefly touch upon what's the difference between context, state, and memory, and this would be regardless of LangGraph. This is going to be a concept which would be used for any sort of RAG use case. And then finally, how LangGraph specifically helps with the state management. And then we also would go through an amazing travel agent demo. All right, let's talk numbers. I love numbers because it gives us the whole landscape of what exactly is going wrong, what's important, what to concentrate on. About 42% of the AI use cases in 2025 failed. And these use cases are not POCs or toy demos. These are actual enterprise initiatives which have budgets, real deadlines, real timelines. Well, that's a significant number. And the funny part is about 51% of these were actually enterprise AI RAG use cases. So where is RAG really used? If you think about all the chatbots, like for example, the booking.com, if you want to book your trip, and if you're thinking about some of the chatbots which pop in annoyingly when you're trying to book something, maybe it's a flight. So these are the different RAG use cases. It's used in highly regulated industries, such as finance, hospitals, schools even these days. So this is something which is extremely, extremely broadly used. And S&P Global did this survey where they interviewed about 1,000 different companies on how RAG is working for them. Believe it or not, just 200 of these companies was able to deploy the RAG solutions successfully. The rest 800 of them actually failed miserably. This is a huge number. Well, the good thing is we started off with this RAG use case in 2024, and we had about a year to experiment, actually see what's working, what's not, and we definitely, I wouldn't say got lucky, but we got really successful, and we got ourselves featured on Microsoft Customer Success Story because we were one of the first enterprises to deploy the RAG solution. So through this complete journey of what the heck is RAG to actually nailing RAG, at least to an extent, I was able to strategize all the different failures that happened and present it to you today. So before we go to the failure zones, let's understand why is RAG essential. As you all know, ChatGPT and all the other LLMs is basically trained on Reddit data, YouTube data, and all the different data which your company does not really have. Your company has a specific set of documents which you would need to ask questions and get answers from. Secondly, I have seen a lot of industry veterans who've been working at a specific job doing a specific critical task for about 20 to 30 years. When they walk out the door, all of the knowledge just follows them. If they don't have a specific documentation, which is sort of decentralized, then definitely the company is at a loss. Thirdly, how many times have you tried searching for that one specific DB name through all of your wiki, asked so many friends and coworkers and really did not get it? Traditional search really fails when it comes to companies. And finally, this is my favorite because all of the regulatory and the compliance and the auditors want you to fail, because then they can make a lot of money out of you, right? Your company is going to get sued because it gave you wrong answers, just like how Air Canada really, it had a blooper where I think they asked for a refund and the chatbot promised the refund. When the person just got back and asked the actual company, they said, oh no, that was just an error. It's not really us, it's the chatbot. But in reality, it's them. They would be losing a lot of money. So we don't want to be there, which is why RAG is super, super important. Now that we understand why is RAG essential, these are the different pillars in which the RAG failure actually happens. At least these are the ones which I saw while working through the projects at PIMCO. So strategy failures, data quality, prompt engineering, evaluation blind spots, and governance catastrophe. If you want to read more about this, I have written a detailed article at the link below, and I think the slides would be delivered to you, so you can definitely take a look at it. Oh, I'm not sure if you can see that, but I think it's much clearer there. Beyond these failures, what I have noticed is, within these past couple of months, it's not just these 5 different pillars which have the issue. There's something called as the state. Memory. That's much better, thank you. Yep, even better. So basically, other than the 5 different failures, we have these critical chain of failures which is related to context, stateless system, wrong retrieval, and hallucinations. What exactly does these things mean? Have you ever observed in the chatbots where you ask a question, say for example, I want to book a trip to a certain place, Indonesia, and then the next question that you ask is not really having that previous context, but you're just going to say, maybe I want to stay somewhere near the beaches, so you just say near beach. And so many times, I've seen that the traditional chatbot really do not persist this memory or the first question which the user has asked. So this is called the context and the memory. We'll talk more about it in the next few slides, but this is a main failure that I've observed other than the 5 pillars. Let's take a look at this specific conversation I was having literally just 2 days back. This was in booking.com. I am not sure what went wrong on the behind the scenes, but standing in their defense, it's AI chat beta, that's what they call it. So I asked them, I asked the bot saying, I'm thinking about Bahamas in December. And then the next question is, what's the weather like? It was able to come back and say that, oh, she was asking about Bahamas, so I know what it is. But the next 2 questions I asked, if you see it, it clearly tripped. Something went wrong. It wasn't able to understand what I was referring to. When I said, show me hotels near the beach, it asked, what beach, what hotels? It does not really remember. And the last one is actually make that under 150. It's supposed to aggregate all the different questions that I've asked and apply the filters so that it narrows the searches to the hotels, which is just $150 or lower. So why did it really fail? Why didn't it work? What exactly happened? So basically, back to Colin's point, the memory is not being stored. What is memory? It's just a list or a dictionary where you append the previous conversations, questions, the responses, along with the context, and then you move it along the state to the next few conversations. That's the root cause of why it did not work. So what exactly is state, context, and memory? Let's take a brief look at it. So memory, if you think about it, is like a history book. It contains all the different things that you've talked about. Context is like a chapter. What are you currently talking about? State is an orchestration layer which carries memory as well as the context. So state is what is persistent across the different phases within the LangGraph. And LangGraph is able to orchestrate this complete flow and keep everything intact so that the users don't get frustrated and get complete answer. So in order to remember this, I really like this, like these two definitions. The memory plus the context is what you need to remember. And state is how you do it. Finally, I wanted to fix this problem on my local, so I quickly use, of course, Claude Code is the best way. Thank you. So if you basically look at it, this is the state flow diagram. The user is asking the question, and you're able to see the complete user journey between the user, the LangGraph, and the state variables, which is being stored at each and every conversation point. So the first time it does not have anything. It's a dictionary, and it's an empty dictionary. It starts off with the state as location, Bahamas. It's able to identify. And it's also able to see what the weather is, because that's what the user's next question is. Then it was also able to remember the preference, what hotels near Nassau was actually the ones which the user liked. So it stored that. Finally, it was able to zero down and give Orange Hill Inn as the hotel, which satisfy all of these 4 criteria. Well, this diagram is pretty much similar to the different one. I was playing around with something called the mermaid, and I was so excited to learn more about that. So that's the reason I had this. This is the user flow diagram, which shows the contrast between the traditional chatbots and the LangGraph. So zooming out a little bit and seeing how exactly could LangGraph be used in all the enterprise use cases, LangGraph enables us to use nodes and edges. So nodes, if you think about it, could be used for dedicating each of the functions, such as retrieval, search, generate, basically all of the RAG. And the best part is it's able to store each and every documents that it identified throughout the different stages. Finally, I was able to basically drop down to 4 different problems. I call it the goldfish problems because the memory is too little, and I would consider LangGraph as the elephant memory because it remembers everything. So it's able to use state graph to persist the context. Then silent failures. This is something which we still see in our enterprise applications because the users might not know what the bot is giving as a wrong response unless they actually see the documents that's been used for it. So LangGraph could use these conditional edges where it goes and checks a specific condition and sees if the threshold is less, then you would just go to a different edge. So this kind of orchestration is going to be really difficult if we were to do it in a custom manner. Thirdly, the audit black hole. Like I mentioned earlier, the regulators and the auditors love to find everyone. So it's the best case scenario because LangGraph basically stores all the different traces and the documents that's used for the RAG. And finally, the orchestration layer, LangGraph is best at it. And I also have an open source RAG repository in case you're interested in contributing and also learning more about it. I'm basically writing everything about retrieval augmented generation, starting off with the embedding, tokenization, indexing, search, retrieval, ranking, all of it. And finally, this is the demo. Unfortunately, I was not able to use my laptop, so please bear with this. I used Streamlit for this demo, and I am basically on the left side showing how the conversation state works. The first question was about Bahamas in December, and notice it, I did not even ask for the weather, and LangGraph, I mean the LLM, I used Claude in this case, was able to immediately understand that, okay, if she's saying December, then it must tie to something, so it's the weather. So LLMs are getting so smart. That's the first question that I have, so the status preserved is yes. And finally, the next question is, show me the hotels near the beach. And notice how each of the hotels it recommended me is about $300, $250, $800. Well, I'm not that rich, so that's when I'm like, nope, does not work for me. I need something way lesser, so under $150 is my next question. And it was immediately able to understand based on the previous two questions and was able to provide me the list of the 3 hotels which actually fits in my budget range. So that's the magic of using context, state persistence, and using LangGraph for this. Well, the next slide was the Q&A. Thank you all so much.
Thank you. What questions does everyone have for Anu?
Would you mind, I've never actually heard of the state component. Could you perhaps clarify the difference between state and contextualization? I think I missed that part of the slide.
Sure.
Anu, can you repeat the question for the remote audience?
Sure. So the question is, what exactly is the difference between state and the contextualization? So I think the best way is to go back to the slides that I had. All right. So basically, context is when you have the conversation with the bot. Say you're asking a specific question to the bot. That's the current context paradigm. And memory is something which already you had asked previously to the context. And state is how you store all of this information. So state is almost like a data structure. You just store all of this information, and you're able to pass this as an object to each of the call. So that's the state persistence.
So for, like, if you're thinking about it, like, from a data management perspective, the state, that information would be stored, like, I assume, like, some type of vector database, like within a, what's the structured form of a data lake? What is it, like a?
In our case, we use the Postgres, and we also use the Cosmos DB.
Okay.
Basically, a database we are able to store all of the conversation sequence that's happening, along with the search results in case it's a RAG.
So, like, from an enterprise level, how are you able to ensure against fault tolerance? Like, if you're just using a Postgres database, like, what if I'm constantly calling the database to retrieve information, and then one day, you know, like, if you remember what happened with Azure, what if I'm screwed? You know, I mean, do you guys have anything that might address that?
We actually do use Azure. I said Postgres just because I'd read about it and I heard a lot in the demo. So we do use Cosmos DB. I would say the only way that affected is we had a downtime of about 15 to 20 minutes because we are showing, we are basically retrieving each of this information on a minute-by-minute basis. Yeah. And we have a dashboard where we show how the interaction is going with each of the user, what exactly are they asking, what's the responses, what's the threshold, all of that. Okay. So we had a downtime of about 15 minutes. That was the,
Okay.
So I have a question. You mentioned that almost 41% of RAG failed, and that was because they didn't have the context, right? When you ask a question, it doesn't keep that in mind. Is it like difficult to implement? Because I have seen a lot of chatbots online which are still struggling with that.
well, I would say context is the tail end of the problem. I would say 5 to 10% of it suffer with that. But the first 5 pillars which I showed you, which is strategy, are you even choosing the right problem? Second is data quality. Are you having documents which is complete and does not have any random metadata? And then thirdly, are the prompts up to date? Does it really align with what the subject matter expertise are saying? And then finally, evaluation. Maybe you don't even have a golden data set, and you're just like making the RAG work on the enterprise. You're not taking much feedback from the users. So these combined would cause the failure of about 42% of the enterprise RAG which fails. This would be about, I'm not sure, I don't want to put a wrong number to it, but this definitely has an impact for the user experience at least, because there's a lot of likability scale feedback that the users have, like basically like or dislike how you do in ChatGPT. So the user experience is just going to be bad, and you might even lose the customer if the chatbot does not remember.
Yeah, that's the basic problem that we are trying
Yep,
to correct.
exactly.
Awesome. Well, thank you so much, Anu. Can you give her another round of applause?
Thank you.
Doing? Good? Wednesday?
Good.
All right. I'm Collier. I'm a machine learning engineer. I work at Cloudflare. I'm going to talk about deep agents. This is the second talk I've done here on deep agents. Last time I went over kind of like the high level, what is deep agents, how does it work. I'm not going to go that deep into the weeds this time. I'm just going to show you an example of using it. And I'm going to give you like an honest appraisal of my experience using it and what I like and what I don't like. But first of all, this is what deep agents from the LangGraph or the LangChain docs says when to use deep agents. So use it when you need to handle complex multi-step tasks that require planning and decomposition, manage large amounts of context, delegate work, persist memory. So why would you not just use LangGraph for that? Well, the short answer is you still can use LangGraph for stuff like this, but this is fundamentally a different like paradigm of agentic workflows that is built on basically after what Claude Code came up with their planning and task decomposition, context management, subagents, and long-term memory. They basically took what they thought was the best attributes of Claude Code and built it into this library. And then just a reminder, it fits in with LangChain and LangGraph. And deep agents can be deployed, yeah, anyway. So, okay, so I wanted a use case and I wanted to see like, can deep agents do deep research? And they're not the same thing. Deep research, I'm sure some of you have used. You basically ask an LLM a question, it takes a while, it goes through a bunch of stuff, it comes back with an answer. It goes through tons of context to figure out what the like best answer is for you. I wanted to do something similar. So I came up with a mini project to work on. Did anyone watch the NVIDIA keynote last week from Jensen? It's okay, it's not, anyway, he gave a talk about a lot of stuff. He talked for like an hour and a half. So what I wanted to do is I wanted to see if I could take the learnings from his talk and try to find interesting companies out there that are doing what he's talking about. So what he talked about in his talk was a bunch of stuff, and this is a meme, but basically he's the merchant of the infinite money merchant. Yeah, Jensen's amazing. Anyway, so the themes he came up with in his talk were the dawn of a new computing era, and this is, by the way, as a result of the deep research, deep agent process. He also came up with AI factories, that's another theme, physical AI and robotics, and then some trends, the end of Moore's law, accelerated computing, the virtual cycle of generative AI, digital twins and simulation. By the way, I don't know what all these things mean, but if any of you do, then maybe we can talk later. But anyway, I basically started the process getting this, and the goal was to take these themes from his talk and then go through a list of about 400 tech companies and look at their company descriptions and say, do any of these companies match up with the themes that he's talking about? Do any of these companies fall into those themes? And then if they do, take the top 100 and go through each of the press releases for those companies and see, do the press releases make the case even more that they fall into this theme or not? If not, then it doesn't move the needle. But this is a useful exercise to see, like, hey, what companies are out there doing the things that he's talking about, these cutting edge things in this new world of AI and computing. And so this is my deep research use case. So there's a few ways I could start talking about this. I think probably, I can either show the results first or I could show the code and stuff first. I think I'll show the results first. So I showed already, basically the results of the first part of the process, which is getting the themes. And then I'll show the final result, which was this list of companies. And this is what the deep research came up with. It says, analyzed all these themes, validated 87 of the 100 matched companies with press releases, and then here are the rankings of all the companies. And basically the highest rank that it started with was 10, but then you tack on the press release stuff, and it can go, basically you can have a final score higher than 10. So anyway, we had like everything from Microsoft, NVIDIA, no surprise, to Astera Labs and CoreWeave, and it just goes down and down, and the lower you go, the less these companies may match one of these themes. But anyway, this is like the final result, so I'm kind of showing you the end first. So what was the experience like to get this? This is like a ton of content, right? It's 244 pages of content. So clearly, I think this falls in like the deep research type of use case. So let's show the code really quick. Let's show like how this works. Can I zoom in? Because that's really small, right? Yeah. Let me just do this really quick. Make it bigger. Let's do like font of like 18 or something. Huh, that didn't work. Okay. Wow, okay, that's surprising. Well, okay, let's skip the read. I mean, the README is whatever. So anyway, deep agents looks like this with the code. You basically create an agent with this create deep agent function, and then you give it tools if you want to, a model. The model I used was Google Gemini for this. I found that it was a little faster than Claude Code, or sorry, Sonnet 4.5. So yeah, that's what I used. And you start out, you give it a system prompt, and in this pipeline, I'm saying there's 4 subagents. So one of the subagents does the transcription. It goes through the transcript, finds those themes that I showed you before. The second one goes through all the companies, finds the descriptions, and then matches them against the themes. And then the third subagent goes through all the press releases, finds those for each company, and says, does this back up the claim that this company falls in this theme? And then the final agent ranks all the results and gives you the top 100. So four subagents, and this is what the subagents look like. So there's these 4 right here. And the way this works is you would just go define any of these subagents as a LangChain agent, which is new, which is what Colin was talking about earlier. So you would do, from LangChain import, from LangChain agents import create agent, and then you would start just making subagents. So the first subagent, I just mentioned, goes through the transcript. It has a system prompt. This basically just tells it what it needs to do. I gave it this, so we haven't talked about middleware, but Colin talked about it a little bit. It's, this is new, and it's really powerful, and it's basically ways of giving your agent to do stuff before it does things or after it does things. And it's super useful. So I gave it this S3 system middleware so that it could write to stuff on S3, in this case R2, Cloudflare. So it could read and write files from there. I used this kind of remote bucket as a place to put all the files. That makes sense if you're running stuff in production or running stuff in any like serious manner. You usually want remote file storage or remote database or whatever. The second middleware was content truncation. Didn't really matter for Gemini because the context window is so big, but for some LLMs, you want to truncate the content so it can fit in context window. And then logging. Logging does not come out of the box with deep agents. You'll have to add your own middleware. And so I added this one. And by the way, this is all be on GitHub if you want to take a look at it, copy it, whatever. But what I found is if you start running a deep agent process, it can take a really long time. And if you don't have logs, you're going to be like, what is going on? I'm just going to give up on this. So the logging middleware is super important. The second subagent, company matcher, goes through all the companies, looks at the descriptions like I already mentioned, and it writes the results to S3, R2. And then the third one goes through and does this validation process. So end up getting like batches of companies to start with. Looks like this, so this would be like a list of companies to go through, and then the next one would go through each company and find the key evidence, that's the PRs that back up the claim that it's in this theme. And so these are links to press releases, and you get a original score, like, hey, this company Adobe falls in these themes, and it has a kind of a weak score of 6. But then we went through these PRs, and we adjusted the score up by 1, so now it's 7. So that's what the validation agent did. And then the last agent just combines all of these files over here and gives you a final ranking with all the companies. And that's kind of what I showed in that Google Doc earlier. So yeah, I mean, it's just kind of reading and writing stuff to R2, S3. Talk a little bit about just some the experience of doing this. So I found that it's kind of hard to keep it on track and have one agent do one thing, the next one do the next thing, and expect everything to be seamless. So I found that I encountered stuff like schemas would be written wrong. It would in my model file, I say, hey, you need to write the file like this, and it would write it with a slightly different key or something like that. Or things like, hey, I need you to loop through all 100 of these companies. This is in your system prompt. I want you to do that. And it would loop through the first 10 and then be like, oh, I did enough. I'm good. You're good. And it's because these LLMs are fine-tuned to save tokens. So they will just naturally kind of take shortcuts. Even the good ones like Google Gemini or Claude, they'll do this. And so you have to be very explicit and super clear in your prompts what you're telling the deep agent to do, because it will deviate, and the weaker your prompt with the more gaps in it to fill, it will just take shortcuts. So that was kind of an unfortunate thing. And I think everyone's seen that has used any of these planning agents like Claude Code or anything. You do have to keep it on the rails, and this is the same thing. Basically putting the schemas in the prompt, just printing it out, and also putting examples of an example in the prompt as well is a good idea. Here's how the schema should look when you actually fill it out, not just the field names and stuff and field types. And so the prompts, that's one thing that's really important. Second thing is you can actually use the middleware to keep it on track too, which is really nice. So all of this middleware has this agent middleware here, this class. They all have this after tool call hook here and then before tool call hook. So what you can do is you can make it check stuff after it runs, you know, a tool call or an inference or whatever, and you can have some check there. And so if it fails the check, then you can yell at it, basically. So here's an example where it's like the number of matches in the company matcher doesn't match what the expected one it was, and this happens before the tool call. So in this case, if this failed, all of this would get printed back to the agent, and the agent would actually see this error message and correct, because it sees, oh, I'm about to call this tool, but this before tool call failed, and now I'm getting yelled at. And now I see in the code why I'm getting yelled at, so I can go fix what I was just about to do before I call a tool, and then call the tool the right way. And so it gets very meta, where you're kind of like almost letting it, it's like having a toddler or something, you're letting it kind of fall down and be like, well, now you know not to do that. And it's kind of, it's a little metaphysical in that way. You're kind of giving it, you're giving the error messages back to it, just like you would when you're using Cloud Code or you're vibe coding or whatever. You're like, hey, this failed, here's the error. You're doing it now in your program, like at runtime, and it's course correcting from that as it's executing, which is kind of a weird thing to think about doing, but that's how this works. And so I found that between the middleware and designing the tool calls in the right way that like really nailed down how to do things, you basically just yell at the agent a bunch and it does things right. And if you don't do that, it'll deviate and get off course and do things wrong. So that's just a experience I encountered. So how long did this take to run, and how much did it cost? So this is LangSmith. This is how long it took to run. It took, and this is a huge job. You know, it has to run through a transcript, 400 companies, and validate each one against a bunch of PRs. It's a lot of work, but this is how long it took. I started last night at 12:38 a.m., and it finished while I was asleep at about 4 a.m. So, you know, it took a long time. It burned about 11 million tokens, and it cost, I'm just seeing this actual cost for the first time. It burned, you know, about $80, which is like, wow, that's a lot. You know, I don't know how that compares if I'd run this with like Sonnet 4.5 or Opus or something like that. If anyone else wants to test, please. Anyway, so it is expensive and it is very token intensive, and this kind of goes back to, you know, as I'm testing this stuff, could I have just done this in LangGraph and gotten it way faster, way less tokens, way cheaper? And the answer is definitely yes for this use case. But it wouldn't have been the same type of agentic workflow. I wouldn't have been like letting it make decisions and stuff like that. And so it was, for this use case, this is pretty deterministic. A lot of use cases like this are not. Like this may not even be a real open-ended deep research use case. So in some cases, you definitely want to give it more leeway to go figure things out and do stuff. In this case, this is kind of specific. It was like, hey, one agent, next agent, result. So it's up to you to determine if your use case is suitable for deep agents or not. Not all of them would be, but I thought this is at least a good learning experience. This also makes me want to have like my own hardware to run stuff on. Yes?
When you say that you can run it much faster, I know this is not perfect use case, but how much faster can you run it?
Well, I mean, with LangGraph, you're not letting it figure stuff out. You're just telling it what to do. It's like very deterministic. So when Deep Agents runs, just like Claude Code or anything like that, you see it kind of thinking and figuring out, hey, I need to do this next. I have a to-do list. I'm going through the to-dos. Oh, I didn't do that to-do right. I need to go back and finish it because that's part of the middleware is yelling at me now. So that kind of whole like 2 steps forward, 1 step back type thing, it does spend more tokens. It does take longer, whereas LangGraph just straight through.
So you're saying that maybe in a document, when you're working on a document, you didn't just follow. Like when you say with a plan, I mean,
Yeah.
one single person, still with a plan.
Well, let me show you the log. So I did send the log to S3, and I can show you kind of how it thinks when it's running. So here's the log, and so this is when it just starts out. So it's using this write to-dos tool, and so it's actually writing down the to-dos it needs to do. So the first to-do is call the transcript analyzer agent to analyze the transcript file. The second one, call a company matcher subagent to match companies from the themes, analysis JSON, et cetera. And then there's a couple more agents. And then as you keep going, you can see it completed the first to-do, and now the second one's in progress. And then as you keep going more, it completes the, if I can, this will take a little minute, but let me just write to-dos. Yeah, anyway, so then it completed the second one, and eventually it gets through all its to-dos and it's done. But you can kind of see the timestamps going by on the left. It's like, you know, minute by minute. So it's thinking as it's going. It's like, hey, I just did this.
It's actually writing the file.
Yeah.
So like as a, you were talking about us having trouble, say, staying on track and going through like every company file. Is there a way to just add in some tool to do like a for loop of all the files that it generates?
So you could do a tool that you just call it and wait for it to finish, and it could call do another LN invocation or something like that. That kind of gets back into like, hey, should this be LangGraph instead? Whereas this is like, hey, I'm telling you what I want you to do, just go do it, and here's the things to hopefully keep you on track, the middleware, you know, checking if you're off, if you skipped a ticker or whatever. Yeah.
So if you call the tool, I'm just thinking usually for this kind of stuff, use protocol, MCP protocol. I mean, is this connected to MCP?
It could, yeah, you can definitely connect this to MCP. Yeah.
So, but is it out of the box? Or you have to
It actually, in their docs, I think it's on the README of the repo. Yeah, I mean, it's definitely out of the box. It's like very, yeah. So anyway, I mean, it was a fun experiment. I think I will use this for some use cases. Some things it may not make sense financially or from a time perspective, but it's really powerful stuff. I'm just getting started playing with it. It's, you know, you can do a lot with this. The first use case I showed was more open-ended. It was just like synthesizing two data sets together and like coming up with a report. And that worked really well. It ran in like a minute or two, and it created, you know, like a 500-word report for me. I'm still happy with the content that it came out with here. I mean, I had to pay a human to do this would probably cost a lot. So if anyone wants to buy this, I'm just kidding. I'll just give it away for free. Yeah, we could, no, it's free. If you're looking for good investment research, and you actually know about these companies, I'd be curious because you could tell me, is it BS or not? That might help. So.
What did you use for the first part where you took the NVIDIA talk, like drop a transcript and then run it through something?
That's all part of the agent. That's the first sub-agent here. It's just goes through the transcript and the prompt's right here. I mean, it's pretty open-ended prompt too. It just says, read this file in S3, analyze it to identify themes, trends, focus areas, write the analysis. And so even that like very open-ended task, you know, produced basically this whole document here. Yeah.
You're getting the data right there. So and this the part where how do you get the data from?
Oh, I already had all this data. I'm a stock market nerd, so I already have all this stuff. I'm happy to share it if you want. If anyone else wants to do this.
I wonder if there's a
Of course. Yeah. Again, tokens, tokens, tokens. If you want to spin the tokens, you can make it do whatever you want. You can have it go search and pull stuff. The quality may be something you want to verify and lock down a little bit. The data in there, I'm pretty happy with the quality, so I was ready to just turn it over. But yeah, it's all about data. Everything comes back to data. Do you have it? Do you trust it? So yeah.
You're mentioning one of the bigger problems you had was with it not adhering to schema and the whole YAML primarily is like straight back to doing renting. Did you try using structured outputs at all?
I did. That was the first thing I tried. I think there's some kind of, this may be a skill issue or just me not figuring it out, but there was some hitch there with deep agents and structured output that was a blocker. Like something, maybe it was to do with the middleware or something like that. It's probably on me, but most of the time when you use structured output, it's through one LLM call. It's like one LLM call, structured output, and it's not a tool call. It's like the LLM, it's like an AI generating a response in a format. This is like hundreds of LLM calls. So it's kind of like, where do you even put the structured output for the LLM to use? Because it's like making so many calls that you kind of have to force it just to use a tool if you want a structured output. And that's mostly what I did. So for like a lot of the stuff, there is tool outputs, but when it comes to like combining all of these validation files, for example, and re-ranking them, that is like, do you really want to write a tool for that, or you just want to let it do that? And then if it screws that up, can you yell at it through the middleware after it did it, before it goes to the next step, to then have it be like, oh, I just did that wrong, let me go back and do it again. So it's kind of like, there's no right answers. Like you'd force it to use a bunch of tools, or you could have it get checked after it does every step and then goes on to the next step with the middleware. It's a little unclear to me actually, like what the best approach is, but I found that for my use case, it was skipping a bunch of stuff until I added these middleware checks, and then it stopped, and then it was like back on track because I kept yelling at it when it would skip, and it'd be like, oh, I just skipped a ticker, I need to go back. So it's kind of a bad answer, I'm sorry. Yeah.
For the middleware checks, were you using another agent to check the output?
Nope. It's all like it's all self-encapsulated. So for example, the one I was just talking about, the validation one down here. So this is the data model it's supposed to write out. It looks like this. The results should come out looking like that. And so I'm telling that in the prompt. And I'm telling it, not basically, these are the things you're forbidden. You can't query the same company twice. You can't skip companies in the list. Telling it very specifically, don't skip anything, don't take a shortcut, anything like that. And then the middleware part is there to keep it on track. So this validation file tracker middleware tracks when validation files are written, and then basically after the tool call runs, it checks and makes sure that like, hey, we actually have a file written out that is the one that you just said you wrote. And if it's not there, then we have an issue basically. So yeah, a little bit of trial and error, and I'll be honest, Claude wrote a lot of this, and I was just like, is it gonna work? Yes, okay, great. So it took some trial and error, and it's definitely worth thinking about, but the middleware is, I think that's my biggest takeaway, is it's super powerful, and it'll really keep these things on track if you design it well and you basically have it like block the LLM from continuing, or the agent from continuing, because you set up the middleware correctly.
I mean, so I know that what you said, that it's actually a single channel, but will the middleware be injected every single time, or is it just an issue?
So it's for the whole subagent. You set up, you just have this middleware, whatever you want to give it. You don't have to give it any middleware if you don't want to. I gave it all this stuff so that I make sure every agent logs with the logging middleware. I gave it this content truncation thing, just in case it ran over the context window, it would truncate, so it didn't run into context overflow issues. I gave it that file validation tracking middleware, and I gave it S3 middleware so it would be able to access stuff on S3. So we could probably do a whole talk on just middleware. Anyway, thank you so much. Appreciate it.
Thank you. Thank you. Does this thing work? I think it does. Anyways, thank you so much, Collier. I think you're right that we should do a talk on middleware. Yeah. Yeah. There's a few of us gotten really excited about it. I'm trying to learn it myself. Next, we're going to give it up for Paul Phelps. He's going to be presenting remotely. So there's those of us who know Paul from his time in Austin. Paul moved down to Panama and actually started an AIMUG chapter down there. There's 100 members. So we're going to give it a try. Paul, we're going to turn your audio on.
All right, thank you very much. And boy, that's my worst nightmare, following Collier. What an awesome presentation. I'm an experienced project manager. Hi, everybody. I'm going to use the role title project manager and product manager interchangeably, but I'll probably say project manager more often. That's my background. Pre-LLMs, I'd ship some AI systems into production, usually working with developer teams or building something small myself. I'm not a coder, but I would muscle through some little algorithm that would do something pretty cool and pretty powerful. So it was, again, pre-LLMs, it was some heavy lifting to try to get these systems to get trusted by the organizations that I was shipping them into. And that still is a problem. This sort of is calling back to Anupama's presentation earlier. This is another perspective on why AI has such a hard time getting into production reliably. And in my opinion, the constraint is not so much the model, RAG accepted, but the organizational approach. So I'm going to talk about the organizational approach. We're still early and learning which patterns work, so I just wanted to cover some patterns that should increase odds that your particular AI systems may be able to get shipped into production and not get blocked. So you build a model, it works perfectly in your notebook, 95% accuracy, clean code, great performance metrics, but 6 months later, it's still not in production. This might sound familiar. The block is almost never your system. The block is organizational process and project manager assumptions, because product and project managers are still using legacy software as a service or ERP mental models. So I'm going to compare some frameworks that are available, going to identify some failure patterns and spot some red flags with the goal that by the end, you'll be able to increase your odds of getting your AI into production in your organization. So why traditional project manager playbooks don't fit AI? So the normal playbooks are those related to software as a service, SaaS projects, most notably, where traditional project manager frameworks are built around the idea of trying to get a predictable and testable software into production. And AI doesn't really fit that pattern. An example might be something simple like what Colin was talking about earlier. You put in with the SaaS software, you would put into an input A, it's always going to give output B. And AI doesn't do that necessarily. For example, if you've got a categorization for different text, like say it's user tickets, support tickets, something like that, you could have the identical text from one support ticket to the next, get two different categorizations, maybe based on some very, very subtle different changes in context. And because of that, that makes it really difficult to pass by some of the roadblocks that happen inside an organization where they're going to say, but why did your system not give the predictable and testable output we were expecting? And it's because AI is different. And AI requirements also evolve as we learn what the data can actually do. So it's not like we know necessarily based on all of the data that's being put into the system that you're building, we don't know that the only possible outputs are going to be A, B, or C. It can be all sorts of things. So, for example, if you were creating a system that's going to create categorizations and you are like, give me 5, you may find that when you put all the data into AI, you may find that actually there's 12 categorizations that the system can fairly well put it into. And so putting all this into context, so traditional project managers, they panic at stuff like this. They panic at evolving scope. But with scope, AI is a signal that system is working and it's potentially cross-departmental. Whereas in traditional ways we've been looking at software, scope is failure. Bunch of other differences, but including training and documentation requirements and blah, blah, blah. But those are just some of the big ones. So those are examples of when your product or project manager is thinking the way they always have and not thinking about AI. So what I want to talk about now is the rare occasion when your product or project manager, they know that AI is different. And so they've gone out and sought out a different framework to utilize how they're going to organize the project that you're building. And there's about a dozen or so big companies that have released their different frameworks. In my opinion, not one of them yet has kind of nailed it exactly right. But I wanted to bring up 3 of the big ones. First one would be Accenture. So if you're not familiar with Accenture, Accenture is a consulting firm that is a sort of business first consulting firm. They're generally hiring MBAs straight out of college, for example. They're going to teach those guys and young women some how Accenture does what they do. They're going to, it's great training, it's great stuff, but it's coming at these workflows, these projects from very much an MBA point of view, not a developer point of view. So inside their AI framework, if you were to go and read it, like I unfortunately had to do, you're going to find that it's mostly about the maturity of the organization. It's going to be about training people on AI, getting them familiar with AI, making change management easier because everybody in the organization is bought in to the vision and to the potential of AI. But this really does lean heavy into what Accenture, what their interest is and what their lens is, which is they want to sell the programs to these big companies and they'll charge hundreds of thousands of dollars and sometimes more for these programs to kind of teach and coach and get the organization ready for this sort of thing. In my opinion, it's often unnecessary. It certainly isn't the biggest priority. Google and Amazon, both of their frameworks are fairly similar. Google focuses on infrastructure readiness and Amazon focuses on data readiness. And based on what it is that they're selling to these big organizations might give you a pretty good clue as to why they care about those respectively. Obviously, Google's going to try to sell a lot of infrastructure to the big companies, and AWS is very interested in you putting a ton of data onto their servers. Last one is IBM. Last big one that I was going to bring up here, at least. There's like I said, nearly a dozen more. IBM. It talks about like governance and documentation and compliance artifacts and all this other stuff that, well, you know, IBM not exactly one of those companies that builds fast and breaks things. That sort of leans into their past experience and how they've worked and perhaps part of their success. But it's certainly not moving at the speed of AI. And to me, it sort of reminds me of like being I can imagine most developers, when faced with IBM's requirements, would be like a cop in one of those really bad buddy cop movies where they just want to arrest people and they don't want to do the paperwork. And IBM's there going, no, 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 you need to do the paperwork. So anyway, with all these frameworks, each has its own lens, each has its own priorities. There's different things that they ignore. None of them, I feel, are prioritizing the developer and development. And so I think that that's a big miss, and it's also a big credit to this group actually to be hearing from you guys sometimes weekly and sometimes monthly what your challenges are and what you're able to build. Beer awaits, everybody. Sorry, I'm going to go just a couple more minutes. Project management frameworks, they do share 3 universal assumptions. They want a well-defined business problem. Which makes a lot of sense. Like, even if there's going to be scope creep with an AI system, you still want to start with a very specific, well-defined business problem that the system is going to solve. By having that, it's much more easier to get the buy-in. You don't want to be told, this is our highest priority business problem, solve it with this AI system. And you turn in your AI system and it solves these 3 other problems, but not that one. That's going to be a real big hindrance to be able to get into production. Second thing is all of these frameworks, including the 8 more that I didn't talk about in the last slide, they all are expecting a certain amount of data readiness and data clarity. Like I said, with the AWS framework, for example, they're much more about data quantity over data quality, but they all are talking about data and how it's needed to certain degrees. And so, yes, it's going to be something that you're going to be asked about, and you will need to defend with your AI system to be able to say to your project manager and the other people who are going to either allow your system to get into production or not, be able to defend the data that is feeding that system and how the system is using it. Last thing is they all depend on cross-functional collaboration to avoid failure. And what that is talking about is basically the role that your product manager has, or even a business analyst in your organization has, which is bridging between the administration and the rest of the business and the developer and the developer team. So you got to have that in place. And so if you're find that you're developing in a silo and you're unable or to communicate with or hear from the business side of your business, then it's doomed to fail. So all these assumptions are not wrong. They all require active developer participation. And yeah, so if you can make sure that these 3 assumptions are being prioritized by you as a developer, there's a much more likelihood that your organization should accept your AI development into production. So some red flags to look out for. I'll skip through these as quickly as I can to avoid going long. You want to watch for product managers or project managers who demand complete requirements before any code. So, for example, if you've heard the organization wants this something to be developed, and weeks and then months are going by and it's not being assigned to you, it's not getting into your Scrum meetings, then that's a pretty good sign that your PM is using the old ways of doing things. What they're doing is spending weeks and months, perhaps, doing stakeholder analysis, doing stakeholder interviews, gathering requirements, and documenting everything so that they can give you that same old Bible that you might have received in the past, so that the first version or the first version plus a little bit of iteration is going to be able to solve what it is, the business problem that the project has been designed to solve. But it's not necessary, or I should say, it's not as necessary with AI initiatives. So just watch out for that. And watch out for PMs who insist on one perfect predetermined solution, because AI is non-deterministic. So it's going to be imperfect, and part of its value is in those imperfections. Watch for PMs who want enterprise infrastructure before validation. If you find out that they are buying tons more Azure tools and doing tons of data cleaning and wanting to do all sorts of things for the infrastructure before you've even built anything, it's a sign that that it's not going to work, and they're still thinking about things in the old PM playbooks. So if you see any of these things, watch these patterns early and guide the business towards some discovery thinking. The biggest tell in all of these things is that the legacy software mental models are being applied to AI work. So just make sure that if nothing has changed between the way it used to be done and the way it's happening now, that is a pretty good sign that it's not going to work. So we've covered covered why traditional PM approaches, they break AI projects, reviewed some frameworks that try to fix this, but some of the frameworks still assume a SaaS mental model. So in my opinion, I think developers see the reality in the data and the discovery cycles. I think you guys are able to develop faster than ever. You're able to experiment and do some amazing things with AI. And because you are better acquainted with the solutions, you are also have a much more potential to be able to identify the legacy problems that previously may not have been solvable, but now because of AI are. So because of that, yeah, I'm very interested in hearing from you guys. Perhaps you can reach out to me on LinkedIn or whatnot, because I know we're out of time. And I'm happy to answer any questions that you might have, of course, on top of that. But I'm really interested in hearing from a developer point of view as to what types of blind spots and things that you're seeing from your organizations and the way that they're approaching the project frameworks, because I'm very interested now and have started working on a framework that I think will be much more likely to get AI projects into production. So thank you very much. Yeah.
Thanks, Paul.
Hey everyone, I'm Girish. I am head of AI at a startup called FindHelp. We have headquarters here in Austin, and we are looking to establish and grow our AI engineering team. Right now we are looking for one, but early next year we are looking for a lot more AI engineers. So if you or your friends might be a good fit, please connect with me now, and I've left a barcode that can help you get to the job posting right away. And also, please connect with me on LinkedIn so that you can stay in touch with future openings as we expand more. Thank you so much, Colin. What a wonderful session today. Thanks.
Awesome, thank you. And we'll be at the tavern for the after party. If you want to, I don't know if you want to join us and try to get some engineers. Anyways, so we're going to wrap it up here. I want to thank every presenter, Anu, Paul, Collier, me, for taking the time to share knowledge. It's really what we're part of. I'm going to remind every single one of you that none of us are experts here. Well, I think you all are experts, but we're all just learning. We're all just trying something out, sharing a little knowledge, and accelerating the flywheel. So if you have something that excites you, something that interests you, you can find that thread to tie it back in the ecosystem you heard talked about here today. It can be loosely tied back, right? Very literally and loosely. But really, remember, we're here to learn in the open. We're here to accelerate this flywheel. And on that note, we're going to wrap up here. If we can please